Okay, so we'll look at some examples of partial differentiation. We said at the end of the previous lecture that all the kind of product rules and quotient rules and chain rules, they all still apply. And I suppose before I start this example, maybe we'll just remind you what's going on here. So this z is a function of two variables, x and y. So two numbers x and y go in, one number z comes out. And if you plot the graph, which is all the points of the form input, output, because the input is two numbers and the output is one number, the points in the graph, there's three numbers, there's three coordinates, and that means that the graphs are three-dimensional, they're in space, and they're like this, they're surfaces. And what this thing here, so this is, it's like differentiate with respect to x, but it's called a partial derivative. And what it means is that only x is changing. Y is kept constant. So in this setup where this is x and this is y and this is the graph of the function, the partial derivative with respect to x says how does z change as x changes. So you just go along the x direction, but y is kept constant. Okay. So let's differentiate this thing. Now, differentiating, first of all, we'll rewrite it, kind of set it up for differentiating with respect to x, that we understand that y is a constant. So we'll fix the y. And, okay, what am I saying here? So the partial derivative with respect to x means x is changing, y is constant. So so this x squared times y, only x is changing, so y is a constant. So it's y times x squared. Now the second thing is a little bit different, and we'll look at it here. So 3x times sine of x minus 2y. And actually what I'm going to do, okay, so if I was to differentiate this with respect to y, things are a little bit easier here because this is a constant times a function of y. But I'm differentiating with respect to x, and we've got a function of x here times another function of x here. And what that means is you're differentiating two things multiplied together, you need the product rule. So we will be using the product rule here. Okay, let's go. The partial derivative of f with respect to x. So we do it term by term, fixing constants, but only if the terms are in a sum. So we're going to differentiate that plus differentiate that. This is a constant times a function of x, so we fix the constant y, and then the derivative of x squared is 2x. That's the first thing. And now we need to do a little product rule. Now what I'm going to do is, I'm probably not going to, well, we may have space to simplify this, but certainly what I'm going to do after this line is kind of show the formula that I used. So the product rule says if you want to differentiate two things multiplied together, you do the first thing by the derivative of the second thing. Now the second thing here, if it's sine of x, the derivative is cos of x, but it's sine of a function of x, so we need to use the chain rule. Now as it happens, the chain rule is going to come out quite handy here, but we'll do it nonetheless. So the chain rule says, okay, you got an outside function sine of x and an inside function x minus 2y. It's not sine by, sine of. So the chain rule says you differentiate the outside function. The outside function here is sine of x. The derivative of sine of x is cos of x. The chain rule says you should evaluate at the inside. The inside here is x minus 2y. And the chain rule says you must multiply by the derivative of what's inside. So we must differentiate this with respect to x. So it's a sum, so we do term by term. Now what is the derivative of x with respect to x? It's 1 minus. Now if y is a constant, so is 2 times y. So minus 2y with respect to x is a constant. The derivative of a constant is 0. So that is the first thing by the derivative of the second thing, plus the second thing, which is sine of x minus 2y, times the derivative of the first thing, the derivative of 3x. Now it's easy to write down derivative of 3x is 3, but let's kind of keep it going. If we have a constant times a function, let's fix the constant, and then differentiate the function. The derivative of x with respect to x is 1. Okay. Now what we said is, let's look at this product rule. So the product rule said it's the first thing by the derivative of the second thing, plus the second thing by the derivative of the first thing. And maybe we will tidy it up after all the talk. 2 by x by y. Now this is cos of x minus 2y by 1, which is just cos of x minus 2y. So we have plus 3x times cos of x minus 2y. And sine of 3 by 1 is 3. And what we'll do is we'll swap these around in case somebody thinks that these things are multiplied by 3 and they're not. So plus 3 times sine of x minus 2y. Done. Okay. We'll do another example here. So what have we got? So verify just basically is another word for show. Show that this function z equal to log of e to the x plus e to the y satisfies this equation. Now, what we want to do here is we probably want to find the two derivatives separately, and then at the end we'll add them together and see do we get 1. Okay. So, partial z, partial x. Now this is not log by e to the x plus e to the y. That's just simply not the case. It's log of. So it's outside, inside, so it's a chain rule. And because it's also not multiplied, it's not equal to log of e to the x plus log of e to the y. That's just simply not true. Okay. So it's an outside, inside, it's a chain rule. So I've kind of messed it up here. So this is not equal to this. So we're focusing on differentiating this thing here. So the outside function is log of x and the inside function is e to the x plus e to the y. So the chain rule says you differentiate the outside. What is the derivative of log of x? 1 over x. The chain rule says evaluate that at the inside. The inside is e to the x plus e to the y. And the chain rule says multiply by the derivative of what's inside. And we're differentiating with respect to x. So it's a sum, so we're differentiating the inside. What's the derivative of e to the x with respect to x? Now you can look in the tables, but you want to understand at this stage that e to the x is almost defined as the thing that it is, its own derivative. So the derivative e to the x with respect to x is e to the x plus. Now it'd be very tempting here to write e to the y, but remember, the partial derivative with respect to x means that only x is changing, so y is fixed, y is a constant. And if y is a constant, e to the y, e, remember, is actually a number, approximately 2.718. So this is 2.718 to the power of a constant. That's a constant as well. So something that is a function of y doesn't have any x, and y is constant, so a function of y is constant, so the derivative of e to the y with respect to x is 0. And this is the same thing as, and now here we'll just do a little bit of algebra over here. When you got something by 1 over something, maybe if I ask you to say what this is, you would say it's 3/5. So if you've got 3 by 1 over something, it's that divided by that. So similar story, e to the x divided by this is equal to e to the x divided by e to the x plus e to the y. Okay. Now we also need to differentiate with respect to y. Off we go. Partial derivative f with respect to y equal to. So as before, it's not a product, it's an outside-inside situation. The log of x is the outside, e to the x plus e to the y is the inside. The chain rule says differentiate the outside. The outside function is log of x. It has the derivative of 1 over x. The chain rule says evaluate the inside, e to the x plus e to the y. And the chain rule says multiply by the derivative of what's inside. And with respect to y, x is a constant, so any function of x is a constant. And the derivative of a constant is 0. Plus the derivative of e to the y with respect to y, exponential function almost by definition, is its own derivative. And this is equal to, for similar reasons to before, e to the y over e to the x plus e to the y. So what we're looking at is the first derivative with respect to x plus the first derivative with respect to y is e to the x divided by e to the x plus e to the y plus e to the y divided by e to the x plus e to the y. Now we're hoping to show this is equal to 1, and we've got two fractions and we can add them together because they have a common denominator. So the common denominator is e to the x plus e to the y, and you've got e to the x plus e to the y, and anything divided by itself is 1. This is what's called a partial differential equation, and what we haven't solved it, we've found the solution.